For decades, astrophysics relied on a strict, well-established timeline to explain how our universe reached its current form. In this standard model, galaxies were star-forming engines that ran on a slow clock. Starting from the Big Bang, small gas clouds slowly clumped together, taking billions of years to grow into massive spirals. Under these rules, finding a fully formed galaxy in the first billion years is physically impossible. There wasn't time. This slow growth assumption was the foundational rulebook of modern cosmology, until we built an instrument powerful enough to look back and test it. The deployment of the James Webb Space Telescope overturned these long-held assumptions. Webb looked deep into that first billion-year window, where scientists expected to find only the primitive, isolated gas clusters predicted by their models. Instead, Webb revealed fully grown, ultra-massive galaxies existing when the universe was only 3% of its current age. These red monster galaxies, named for their high dust content, contain nearly as much stellar mass as the modern Milky Way, despite existing billions of years before they were supposed to. These objects contradict our standard cosmological models, forcing researchers to reconcile their existing math with the reality now visible on screen. To understand the problem, we look at the mechanics of how a galaxy builds itself. A dark matter halo acts like a gravitational net, pulling in cosmic gas. Models show this process is inefficient, converting 20% or less into stars. But Webb's data reveals red monsters were hyper-efficient, taking that same gas and producing nearly double the star output. These ancient galaxies reached their massive scale through internal conversion engines operating at an accelerated rate, rather than simply having access to more raw material. This mechanical efficiency allowed these objects to become massive behemoths in a fraction of the time predicted by our best models. The red monsters appear across Webb's data, proving they are a systemic reality, not an isolated fluke. This is best seen in the JWST quintet. Here, 5 distinct galaxies are violently merging much earlier than models allowed, spewing heavy elements like oxygen into space through sheer gravitational force. We are also seeing supermassive black holes that formed via direct collapse, reaching millions of solar masses before their host galaxies were even built. This data reveals an early universe that was a high-speed construction zone, a chaotic departure from the quiet nursery once predicted by our models. Discoveries like these often prompt the question, is the Big Bang itself wrong? Structurally, the theory remains sound. The dilemma is specifically a timing problem. We are seeing too many massive objects forming too quickly for the old timeline to survive. Researchers must now identify the specific physical processes that allowed these early galaxies to bypass the standard speed limits of the universe. The old concept of a sluggish, gradual cosmic dawn is being erased. We now see an era that was densely packed with rapid, hyper-efficient growth. As Webb continues its survey, the foundational history of our cosmos is being rewritten in real time.